Carbohydrates. So one example of a carbohydrate is sugar. All right, so let's take a look at these molecules. So carbohydrates have a carbon-hydrogen-oxygen ratio where we have a 2-to-1 ratio of hydrogen to oxygen atoms. So we have 2 hydrogens for every 1 oxygen. So you can see pictured here, I have a carbohydrate. Okay. Now, we can get different types of carbohydrates. So the first one we're going to talk about is monosaccharides. So glucose and fructose, these are monosaccharides, and these are types of sugar. So in a monosaccharide, we have a single ring, all right? And we've got this one hydroxyl group, and this hydroxyl group gives us alpha glucose or beta glucose, okay? Glucose is a 6-membered ring, and fructose is a 5-membered ring, all right? So glucose has 6 rings in a or has 6 things in its ring. So you've got 5 carbons and an oxygen. Fructose has 5 things in its ring. You have 4 carbons and an oxygen. All right, and then sucrose, all right, this is a disaccharide. So di, 2. So 2 means we're going to link 2 of these rings together. So we take 2 monosaccharides, we link them together, we get a disaccharide. So sucrose, we get an alpha glucose, all right? So again, it's the position of the hydroxyl group. We get an alpha glucose is going to link up with a beta fructose. So we're going to get a 6-membered ring linking up with a 5-membered ring. And you get a linkage, the COC linkage, okay, is going to be this right here. All right, and it cuts out a water. So you can see highlighted in red, this OH and this H. Okay, that gives rise to the water. So when these link up, the oxygen that's on the beta fructose is the one that stays. And the oxygen that's coming from the hydroxyl group on the alpha glucose, that's the one that gets kicked off when it forms the ring. Okay, and so we describe this as a type of condensation reaction, and we produce a water molecule for every sucrose that we make. And then we have polysaccharides. So poly means many. All right, so we can get polysaccharides. These are natural polymers. So we can get different linkages. We have alpha and we have beta rings, and so we can get 2 different kinds of linkages. When we get the polymerization of glucose, again, that 6-membered ring, when we're looking at the alpha versus the beta, okay, if we link off the alpha glucose, we make starch. If we link off the beta glucose, we make cellulose. So the same base can give us 2 different things. All right, when we look at starch versus cellulose, we get starch in a lot of foods. So I like starchy foods. I love potatoes, and starch is very, very prevalent in potatoes. I probably eat too many potatoes because they're yummy. And so you can hear you might have heard that potatoes have a high glycemic index, and it's because they've got these carbohydrates that are coming from starch that is made from glucose. All right, and then cellulose, that's what we see in the cell wall of plants. Glycogen, similar to starch. Okay, we store that in our bodies. That's our storehouse of energy. You need glycogen for energy. We can't digest starch, but we can digest starch, but we can't digest cellulose. So we don't have the enzymes necessary for that. So starch, yay. Cellulose, nay, for digestion. When we look at sweetness, we have natural sweeteners, we have synthetic sweeteners. Now, there's a lot of stuff coming out right now about some of these artificial sweeteners. So they're not necessarily as harmless as we may have thought they were originally. And these guys have really, 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 really high sweetness values. So if you look at our natural ones, the highest one is fructose, and that goes up to 173. But when we start with our synthetic ones, those start at 200. They're incredibly sweet. I find most synthetic sweeteners to be sickly sweet. My mom has the most ridiculous sweet tooth ever. She can dump 3 packets of Sweet and Low into a cup of coffee and still wonder if it's sweet enough. Now, I did read once upon a time that as you age, your taste buds change. And older people, because their taste buds are changing, they actually end up developing more of a sweet tooth as they age. And this absolutely, like, my mom's always had a sweet tooth, but it's even worse now. That I'm in my 40s than what I remember her having when I was a teenager. And so I absolutely, like, empirical evidence in my own life, I would agree with this. And, there's that trope of, like, old people have candy dishes and stuff. And so um, I think that there's something, behind that research that definitely it looks like the older you get, for a lot of people, not everybody, but for a lot of people, the more you end up craving that sweet flavor because you can still taste it well. So I've never had a huge sweet tooth. I actually prefer salty foods over sweet foods. I do like sweets every once in a while, but I get like sweeted out really easily. So I, again, have never been a fan of the artificial sweeteners because they don't taste right to me. They taste overly sweet and just kind of sickly sweet. So I'm not a huge fan of that. And so, and then I'm linking in our Canvas shell, I've got a supplemental video. So as you've noticed with this course, it's fun because I can pull in all sorts of different stuff. And I do like the ACS reactions channel a lot, and our textbook that we're using is ACS based. So it's fun to be able to pull in some outside information that sometimes can go into more depth than I can go into, or they can do flashier things than I'm capable of doing in my office at home. But sweetness is interesting. These carbohydrates are interesting with those sweetness values and stuff.